We are back, and we have been talking about covalent bonds, and we saw that covalent bonds share electrons, and we talked about that there are two nonmetals that have bonded together, and we looked at naming the covalent compounds and giving formulas covalent compounds, and we saw that it was super easy. We don't have to worry about oxidation numbers or polyatomic ions. All we have to do is just look at the prefixes and make sure that the prefixes and the number of atoms in each element match up, and we're good to go. All right? Now, there is another way that we can represent covalent bonds, and that's using dot diagrams. Let's refresh our memory on what dot diagrams are. Remember, we use the dot diagrams to represent the number of valence electrons in an atom. So, for example, hydrogen has one valence electron, therefore it gets one dot. Chlorine has 7 valence electrons, so there are 7 dots around chlorine. Okay, so that should refresh your memory on that. Now, what we can do is use dot diagrams to show the bonds that form between the nonmetals during a covalent bond when we make a covalent compound. Okay, now remember, you can have more than one bond in a covalent compound. So you're going to see how that's going to come into play with this video. All right, let's run them through the rules real quick. Of course, you just look at the name of the covalent compound, write the formula for it, determine the number of valence electrons for each element. All right, and then you're going to determine the number of bonds between the elements and the compound. In other words, you're going to determine how many pairs of electrons are going to be shared between the two elements in 2, 3, 4, however many elements in the compound. And then we just draw the dot diagram, and then we use lines to show the shared electrons. All right, that might not make a lot of sense to you right now, but we're going to try some, and it'll make more sense to you here in just a minute. All right, so let's go ahead and try some. All right, so first we have carbon dioxide. Of course, carbon dioxide is obviously fairly common. So we have carbon, and then the Di tells us that I have 2 oxygens. So let's just write a carbon and then an oxygen on each side of the carbon. Okay, now, if you remember the last time we did dot diagrams, there was a lot of conversation about where the dots go, does it matter where they go, how does that work? And we talked about how it didn't really matter as long as you didn't have more than 2 dots per side on the symbol. Well, now that's going to change. We want the dots to be placed strategically so we can show the bonds forming between the atoms. Here's an example. So we know carbon has 4 valence electrons. Now, if I do 1, 2, 3, 4, that's great, but these dots on the top and the bottom are not going to help us show the bonds between oxygen and oxygen. Okay, so I don't want to do that. All right, and this might be a little hard to understand right now, but as you do more and more of these, it'll make more sense. Okay, so I know carbon has 4 valence electrons, but I want to be able to just show the sharing of electrons between the carbon and the oxygen. So I'm going to do 2 on each side of carbon. Okay, now I know that oxygen has 6 valence electrons, so I'm going to show those 6. Now, if I've got 2 sets of electrons for carbon, then it seems like it would make sense that I'm going to have at least 2 on this side for oxygen and 2 on this side for oxygen as well. So these pairs of electrons can be shared. So let's just stay with the oxygen on the left. So I've got 2 here, so that's 2, 3, 4, 5, 6. Okay, so I've got 2, 3, 4, 5, 6. Now all I have to do is draw my lines here to represent, well, draw my lines here to represent these shared electrons. Okay? Now, let's go through and count these and make sure that this makes sense. I'm going to change my color here. For this carbon, I have 1, 2, 3, 4, right? But then they're sharing these, so this is 5, 6, 7, 8. So my carbon is happy. It has 8 electrons, okay? And its outer energy level. Let's do the oxygens now. So oxygen has, let me change it here. So oxygen has 1, 2, 3, 4, 5, 6, and then 7, 8. Because remember, oxygen is sharing those electrons with carbon. So this oxygen is good, it has 8 electrons. Same thing here, 1, 2, 3, 4, 5, 6, 7, 8. All right, so remember, these pairs of electrons are being shared. Okay, so everybody's happy, and here we go. Here's our covalent bond, and this is actually a double bond here. All right, so we have 2 double bonds. Okay, now that was kind of a hard one to start off with. So if this didn't make sense, don't get frustrated. It'll make more sense here in a minute. Let's do hydrogen monoxide. We saw that's just H2O, right? So I have, let's see. Actually, this is just HO, right? So there's an H and there's an O. That does not make sense. This should actually be dihydrogen monoxide, I think. Actually, it would help if I would read it right. It's hydrogen monoiodide, not monoxide. Sorry about that. I knew something didn't sound right there. Okay, so let's start over. Number 2 is hydrogen monoiodide. So mono meaning 1. So, and nothing here prefix for the hydrogen. So that's I've got 1 hydrogen and 1 iodine. Okay, so hydrogen has 1 valence electron, so I'm going to put that there. Iodine has 7 valence electrons, so I'm going to put 1 here so we can show how they're bonded together. So I got 1, 2, 3, 4, 5, 6, 7. I do put the line there. I'm done. Pretty simple, right? Let's try nitrogen trihydride. So since I have 1 nitrogen and 3 hydrogens, I'm going to put a hydrogen here, here, and here. Okay? Now, I would start with the hydrogens because I know hydrogen only has 1 valence electron. So I'm going to do 1, 2, 3 hydrogens, 1 electron for each one. Now nitrogen has 5, so I want to be able to show these bonds between the nitrogen and the hydrogen. So I'm going to do 1, 2, 3, and then 4, 5 for nitrogen. Put my lines here to show the bonds, and that's it. See if my pen will cooperate. Okay, that's all it is. Now, 4 is a little bit weird. It's just nitrogen. Why is it just nitrogen? Remember Professor Brinkelhoff? So nitrogen is a diatomic molecule. That means it's 2 nitrogens that have bonded together. Okay? Now, nitrogen has 5 valence electrons. Okay? Let's just try this and see how it goes. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? So if I do that, I've got a bond here and a bond here, so that gives me a double bond. Now let's check and make sure this is right, okay? So I'm going to use blue here. So I've got 1, 2, 3, 4, 5, 6, 7. Okay? So that's a problem. I need to have 8, but I've only got 7. Okay? Now, I'm just going to erase this whole thing because that is not right. So let's try and figure out what we need to do here to make this correct. Okay? So a double bond does not work. So what if we try a triple bond? Okay? And you might be thinking, well, if I have a triple bond, that means I have to put 3 valence electrons on one side. And we weren't allowed to do that last time we worked with dot diagrams. Well, in this case, you are allowed to do that because it's going to have a triple bond, okay? So if I've got 1, 2, 3, I can just do 4, 5, 1, 2, 3, 4, 5. All right, and then I can put my lines here to show the bonds. Okay, let's count this and make sure this makes sense. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8. So I'm good there. I've got 8 for this nitrogen. Let's change my color. I have 1, 2, 3, 4, 5, 6, 7, 8. Remember, they're sharing these 3 pairs of electrons. This nitrogen is good. We're all good. Okay? So, it's an example of a triple bond. All right? Now, what I would like for you to do is what we've done in the past with some of these others. I want you to pause the video here. Try to do these next 4 on your own. When you get done, unpause the video and check your answers. I'm going to go ahead and walk through these, and that way you can check yourself. Okay? So, here we go. Selenium difluoride. Selenium is Se, no prefix, so it's 1 selenium difluoride. That means I have 2 fluorines, so I'm going to do a fluorine here and a fluorine here. Okay? Now, selenium has 6 valence electrons, so I'm going to do 1, 2, 3, 4, 5, 6. Now, you might say, well, how did you know just to put 1 there? Okay? Well, fluorine has 7 valence electrons, so fluorine can only have 1 covalent bond. So that means I can only do 1 bond in between the selenium and the fluorine. So I can do 1, 2, 3, 4, 5, 6, 7. There's my bond. 1 fluorine here, 2, 3, 4, 5, 6, 7. There's my bond there. Now I'm done. Okay? Carbon tetrahydride, CH4. So I got C, 1, 2, 3, 4. CH4 is actually methane. That's what comes out of your backside when you let a little stinky. Just FYI. Carbon 4, 1, 2, 3, 4 valence electrons. Hydrogen has 1 each. All right. Show the lines in between. That's kind of hard to see there. Sorry about that. That's it. That's CH4. Dihydrogen monoxide. Here's the water, right? So I've got 2 hydrogens, 1 oxygen. So here's an oxygen. I have a hydrogen, and I have a hydrogen. Remember, hydrogen's got 1. All right? So if hydrogen only has 1 valence electron, it can only make 1 covalent bond. So I'm going to put 1 here and 1 here for oxygen. Put 2 on the top, 2 on the bottom. Draw my lines. There, I'm done, right? Silicon disulfide, silicon is Si, and then disulfide, so I have 2 sulfurs. Okay, so silicon has 4 valence electrons, so that means 1, 2, 3, 4. That means it can make a total of 4 bonds or 2 double bonds. So that means my sulfur, I got 1, 2, it has 6 valence electrons. So 1, 2, 3, 4, 5, 6. Same here. 1, 2, 3, 4, 5, 6. Draw my lines. And I'm good to go. All right. So check your answers and see how you did with that. Again, it might seem a little bit difficult right now, but once you do several of these, it will seem much, much easier. All right. Let's move on to the last thing, which is metallic bonds. These are bonds formed between 2 positively charged metal ions. So that's a little bit different. We have a positive and a positive. All right. And then you have a whole bunch of electrons that surround these 2 positively charged metal ions. Okay. They're really different. So just like the next sentence says here, think of a metal as being made up of positive ions with electrons swimming around it, keeping the ions together. So the positive charge and the negative charges, they're still interacting, being attracted to each other, but you have a bunch of positive charges because you have a bunch of different metal ions, and then you have all these electrons kind of swimming around, so these electrons kind of keep everything in place. Okay? This type of bond is what gives metals their properties, especially the transition metals. All right, it's what allows them to be good conductors of heat and electricity, allows them to be ductile, malleable, and allows them to be able to bend without breaking. And really, that's it for metallic bonds. Okay, All right, I know that probably seems like a lot, but we'll just keep practicing and you will get it. All right? And that's it. Thanks. Bye.